proud that I'm part of this class and I have such amazing colleagues as well.
Oh, I'm glad to hear that. First of all, I love hearing all the math discussions you guys have too. But yeah, it is something to be proud of. You guys have created a really awesome class. So, and that doesn't always happen. We try to make it happen, but it takes awesome individuals like yourselves.
Oh, thank you.
So with that, hi, Denise.
Hi, Miss Denise.
She's there. She is.
Mask up.
Denise, will you mute your mic? Okay. We are going to get started. Before we jump into the lesson, I did want to point out something that's been posted in our Google Classroom. Some of you already have found it because you've already done it. But under week 4, one of the homework assignments that have been posted with today's date is signing up for a student-teacher conference. If you are a return student, you know this is something we've done each quarter. But next week is that halfway point in the quarter. And when we get to that halfway point, that's when I love being able to take some time to meet with you all one-on-one and go over your thoughts on the class and the progress you've made so far, see if you have any questions, all of that. There are a bunch of times available for you to make that conference appointment. If you go to the website Calendly, it's linked right here. It'll show you all the different time slots you can choose from. Each of them shouldn't be more than like a 10 or 15 minute meeting. And you can choose to meet with us in the building now that we have returned to the building, or to do it via Google Meets, like our classes are. But yeah, it's that halfway point. And so I really, truly do love getting the chance to chat with you all individually and see how you're feeling about the class and if there's anything we can do to help, if there's any questions you have that we can answer. It's a great opportunity for us to do that. It says here in the description, if for whatever reason, and I guess this is more towards the people watching this recording, because Deborah and Sheila, you obviously are both free at this time. But if there's someone watching this video who is just like not free during school hours, so like maybe you work a 9-to-5 job or something Monday through Friday and wouldn't be able to make an appointment time, please reach out to us and let us know. Leave a comment on the assignment or send me an email or something. And we can try setting up something for you either like on the weekend or in the evening. But I really, really would like to get the opportunity to meet with everyone. So if you're not free sometime next week, just let us know and we will do our best to make it work. Deborah and Sheila, do you have any questions about the conference? Sheila, I think you already signed up for one.
No, I saw it, but I was trying to wait and review my calendar so that I won't miss it like I did the last time.
You're good. Just you've got until we gave through this Friday to sign up, just so we know what next week looks like. So it's there waiting for you whenever you're ready to sign up. I will switch us over to our lesson we're looking at today. So yesterday we had started writing equations to model relationships, and I had let you guys know that there is going to be a part 2 to that lesson, and that is what we're looking at today. The objective, we're really focusing on patterns in this lesson and using these patterns to help us write equations. For our warm-up, in this warm-up here, we have a table of values. And I'm letting you know that these two quantities, x and y, are related. There's a relationship, meaning there's some sort of math we can do to get from one to the other. Our goal is going to be to come up with a list of strategies you can use when you're trying to find a relationship between x and y. And our goal is to brainstorm as many strategies we can use as possible. I want to emphasize the focus of this question here is not in finding the right answer. The focus is not, can you figure out how these are related? The focus is instead on coming up with a list of strategies. anytime I give you a table and tell you these are related somehow, what are strategies we can come up with? Do we understand what the question is asking for? Okay. Then go ahead and take, let's say like 20 seconds to kind of think of what are some strategies you use when you're trying to figure out what math you need to do to get from one column to the next. And then after 20 seconds, we'll share out and get a list of strategies.
That y is dependent on x.
Mm-hmm.
So we can multiply.
Yeah. So you can check to see, tell me more about the multiplication.
Yeah, one times, I'm coming. When x is 1, y is 0. When x is 3.
Tell me if this is what you're thinking. Are you thinking we're checking to see if there's something you can multiply x by to get to y?
Yes, yeah, that's what I'm trying to figure out.
Yeah. Remember, we're not trying to figure out what that relationship is. We're just trying to get a list. So that's an awesome strategy. We can check to see if multiplication is what that relationship is. What are some other strategies we could use?
Use addition.
Yeah, tell me more.
8 divided by
See if there's anything
8 divided by 7.
add to y to get x.
Yeah, so we can check, we can look for, I'm going to say a constant number to see if you add that, you can go from x to y. I also heard division, so I'm just going to write the same thing for division. What we're really getting at here is like looking to see if there's an operation, right? Addition, subtraction, multiplication, division that gets you from one over to the other. Any other strategies we can think of?
If we try to see if we can go from x to y, something for division.
So far we're looking to see like, is there a number you could add or subtract or multiply or divide to get from x to y? Any other strategies?
I can't think of any.
I'm going to take us back up to the objective. I'm going to highlight that part right there. Using patterns. So we could leave it vague, like we could look for a pattern in the table. That pattern might not necessarily be us getting from x to y, but instead it could be if you're looking to see a pattern of each time we go down, you might notice something and you could always see, is that true on the other side? Is there that same pattern in our y column? So looking for patterns could be helpful. Any other strategies we could think of that you could use to try to figure out how these are related? And this list is a good starting point. We are going to be looking at more tables today. So as you look at more examples and as you're trying to figure out what that relationship might be, you might come up with more strategies. And if you do, please share them out. We've looked at tables before back in pre-algebra. And as these relationships get a little more complicated, like I think this one here is a little more complicated than some of the ones we've seen in pre-algebra, but as the relationships get more complicated, we might need a bigger list of strategies to help us find these relationships. If there's a more complicated relationship here, you might need to use like a variety of strategies to help you really pin down what that relationship is here. But this is, like we said, this is a really good list to get us started, and we can keep building on this as we look at more tables today. It was just a warm up. Did anyone figure out what that relationship is out of curiosity? The fun one. I won't spoil it for you. So if you want to think about it later, you can. We're going to come down to the second part, though. The second activity here is called Something About 400. In a moment, I'm going to give you some time to look through these 4 tables here. And after that time, our goal is going to be, we're going to describe in words how these 2 quantities in each table are related. So similar to before, there is a relationship between X and Y. Our first goal is going to be describing in words what that relationship is. As you're looking through these tables, think about the strategies you had mentioned earlier as you're trying to identify what that relationship is. Also pay attention to what X and Y are. In each of these tables, X and Y represent something different. So using that context could also help you figure out what that relationship is. I'm going to give you guys about a minute to look over these 4 tables, just a minute of like silence, everyone making their own observations, and then we'll go through each table one by one and share out. Io, I didn't see you joined. Hello.
No.
So it is 12:33. We'll come back at 12:34 and start sharing out some of the observations we've got. I want to give you some time just to look at it silently, so I'll stop talking. I'm going to cover up these, or at least I'm going to attempt to, and I didn't do it right. I'm going to attempt to cover up these 3. There we go. These other 3 tables here, just so we all can focus in on this first table here. We've got table A, and these are our values. Our goal, remember, is we want to describe in words how these quantities are related. Does anyone have a starting point for us? Anything they notice that might help us describe that relationship?
I know the values are increasing.
Yeah.
In set of I think 2.5. The first value, that's it's increasing by set of 2.5. So like 400 plus plus
600.
Yeah.
So you're looking at how they're increasing, kind of going from left to right. So you noticed here it's increasing by 600. Yeah.
And,
So I'm just going to say we notice that both X and Y increase at the same time, right? As X increases, Y increases. Any other observations that we can make to help us pin down what that relationship is?
They increases in a different rate of numbers.
Tell me more about that.
Like they don't increase in the same amount of numbers. Like the first 2, like 400 increase with 600. Then the other one increase with 16. Then the other one decreases in 14, like 24, something like that.
Yeah. So you notice as you're moving through all those Y values, they aren't increasing at the same rate. So that means it's going to be harder looking at how it's increasing, looking through all those Y's for us to identify a relationship. If it was increasing the same amount, that would really be helpful for our relationship.
I'm looking at something. I don't know if I'm putting the words together. Why value is in a multiple of X value?
And Sheila, I had a hard time hearing you. I heard you talk about a multiple. You said y is a.
I said y value
Mhm.
is in a multiple of x value. That means we have when we have 400 in y and the x value is 1,
Mhm.
we have 1000 in y and the x value is 2.5. That means we have 400 in 2.5, as in
Mhm.
if we are going to do a division, it's going to be in a multiple of 2.5.
Yeah. So we can build on what Sheila's saying. He's noticing that there's this multiplication relationship, and we're trying to put some words to it, but that idea of it's a multiple is going to be important for this one. We're noticing it's a multiplication relationship. Does anyone think they can build on that?
So can we say that y is a product of the increase in x?
Ooh, I like your word product there. Can we make it more specific?
Uh,
So you said
Right.
y is a product of x and what number? What are we multiplying x by to get to the y?
Yeah, it's in the just a moment. So that's 1000 divided by 400. So we multiply for to get the 1000, we multiply 400 by 2.5. So that gives us the 1000. So then we also multiply the other one by 6 to give us the next number. Then we also multiply the other one by 9 to give us the last number. So y is a product of x in this regard.
A product of x, and I'm putting and 400 because product means you're multiplying two things.
Oh,
What Deborah just modeled for us is a perfect example of how you might want to go about this when you're trying to make this observation of the relationship. She noticed that she thought maybe we were multiplying by 400 based on this first one. She said, well, 1 times 400 is 400. Let's see what I get when I divide these. She noticed it was 400 there. And then she checked herself by coming to these next ones. She said, yep, 6 times 400 is 2,400. 9 times 400 is 3,600. By checking to make sure it applies to all of those values, that's a great way to confirm you found that relationship. So we figured it out, though. You had mentioned earlier for strategies is check to see if you can find a math relationship. And so we noticed first that they're increasing. We pinned it down by it's a product. It's a multiplication of 400. I want to draw our attention to what x and y are talking about because I didn't hear anyone mention those. X is the number of laps and y is meters run. How does that relate to that observation we just made of it's this multiplying by 400 relationship?
So when the laps increase, the meter runs also increase.
Yeah, that should make sense, right? If you're on a track and you're running more laps, it means you're running more meters. Who can bring in this 400 here? How does that 400 relate to laps?
Once the number of laps increases, the meter run increases by 400.
Yeah, so as our laps increase, the meters run increase. Right. Let's focus real quick on what is just this first pair of numbers here telling us.
That means if you run 1 lap, that means you've run 400 meters.
Yeah. So that's where this relationship, this multiplication relationship is coming from. Each lap is 400 meters. So if you run 6 laps, multiply that by 400, you've ran 2,400 meters. You've ran 9 laps, that's 3,600 meters.
Wow.
I heard the wow.
Yeah, I just calculated it now, and that's what you just explained. That's, yeah. So which means that every lap is 400. So if you run 2 laps, that's 800. So if you run 2.5 laps, you run 1,000. So if you run 6 laps, that's, yeah. So I just got the calculation here.
Yeah, that was a great summary, and what you were saying is what we've got over here. So that final description we've got is each lap then is going to be through 400 meters, and that's what this table here is showing us. As you were talking through this, I really think you guys added in some strategies here. The one I want to put down here is pay attention to what X and Y represents. That wasn't an option we had for this table up here because X and Y, it didn't give us context, but noticing that context could help us also find that relationship there. Let's come down. We're gonna, I'm moving all over the place. Let's look at table 2, table B. I can't remember which one it is. Hello?
It decreases by 75.
There you go. Okay.
Yeah.
I couldn't move it, so we're just going to look at all of them. But focus in on table B for me. Some observations we've got for table B. Anything we notice about the relationship between those values in table B?
They are reducing.
Yeah, tell me more. What's reducing?
The Y is reducing, then the X is increasing.
Yeah, so we could say as X increases, Y decreases. Or you were using the word reducing. So as X goes up, Y reduces or Y goes down. Nice. Any other observations we've got?
So I think the meter from home is in relation to the meter to school, from school. So the closer your home, the closer you are to school, and the farther your home, the farther you are to school. So that's the relationship between the meter from home, which is the X, and the Y. So if you're
Wait, Deborah, I'm going to pause you real quick. Sheila, what did you have feedback?
I'm trying to talk about what she just mentioned. That the distance from the farther you are from home should be the closer you are to school.
Yeah, so as you get further away from home, as this number gets larger, you're getting closer to school. Deborah, I think it's possible that's what you meant, but we were saying that as you get farther away from home, you get farther away from school. That would be something like this. Yeah. Deborah, you were going to say something else.
It just escaped my mind.
Oh, I'm sorry. I stopped you. So we're noticing as X gets larger, as you get further away from home, you're getting closer to school. We're trying to pin down what the exact mathematical relationship is. See if you can make any observations about those numbers.
That means the distance from home to school is 400.
So the distance from home to school is 400. What do you notice about these other pairs of numbers?
So,
so if the distance from school is 400, so if your home is 75 meters away from school, then you are at 325 meters to the school from your home. So which means the 400 the 400 is the constant, which is the actual meter from school. So if your home is 75 meters away from the school,
I'm not sure if I'm cutting in and out or if you are, Deborah.
You said?
Deborah, I don't know if I cut out or if you cut out. Will you say that one more time? I could tell you were onto something great.
Okay, what I'm saying is the 400 is a constant, which is a meter from school. So invariably, if the 400, if the meter from school to any house is 400, so which means if your house is 75 meters away from the school, then you will be 325 meters to the school, which means 400 minus 75 will give you 325. So if your home is 128 meters away from the school, which means you will be 272 meters from your house to the school. So, but the 400 is the constant. The others are just the variables that keeps changing depending on how far or how close you are to the school.
Yeah. So as you were talking, I wrote down that 400 minus x equals y. I heard you say if you're trying to figure out how far away you are from school, if you take 400 minus 75, it gives you that 325. That's you pulling out that mathematical relationship. You're also noticing that you said like there's a constant of 400 throughout all of these values here. This is how I heard Deborah describing it. Was anyone else thinking of something slightly different? I just asked because we had seen yesterday how you can have more than one equation. Do we agree with this equation, the 400 minus x equals y? Sheila or Ayo?
Yes.
Yeah. Okay. Then we'll just keep moving right along. So go ahead, direct your attention to table C here. Again, our goal is to describe in words the relationship between these values here. What observations do you guys have?
Both X and Y are increasing.
Yeah, so we've got another table similar to that first one where both X and Y are increasing. Let's see if we can make it more specific. Do you see how they're increasing?
The constant is 485.
Constant is 485. Tell me more about that.
Yeah, the total expenses in dollars is $485. So electricity bill in dollars. So if your electricity bill the constant electricity bill is 485. So if your electricity bill increases, then the total money you spend also increases.
Yeah, so you're putting some context to this. We've got if your electricity bill goes up, so does the total amount of money you spend. I always tell you raise the hand.
How do we know which one is constant? Like, which one is the constant number?
The 485.
So tell me why we think 485 is constant. That's a good question.
One moment, please. I'm trying to work the maths out so that I can give an accurate answer.
Because I notice we're always talking about the first number.
Mm-hmm. Our goal when we're talking about a relationship is we want to see how X is related to Y. Or, I mean, the opposite would be how Y is related to X. But we're trying to see how X and Y are related, not how like all the Y's are related. So keeping that in mind, Io might have a good point. Like, is 485 the constant? If it is, we should be able to explain like mathematically why that is the constant. If not, there might be a different number here. So I'm going to come back to that description Deborah gave us with the context. She says she noticed that if the electricity bill is $85, then the total amount of money you're spending, your total expenses is $485. The electricity bill is $124. The total expenses is $524. So she had noticed as that electricity bill is going up, so is your total expenses because the bill is part of your total expenses. We're trying to figure out how, if I gave you any number for the electricity bill, what you've got to do to figure out the total expenses. What if instead of $85 for the electricity bill was just $80? What would your total expenses be?
There'll be 405.
405?
Yeah,
Tell me why.
because you have the total expenses in dollars to be 485. So if your electricity bill is $80, then you have to take away 80 from 485. So which means the total expenses will be 405.
Or Sheila, do you agree?
So are we subtracting X from Y?
Oh yeah, let's look at that relationship. If we subtract X from Y, what does that equal?
It gives us the total expenses in dollars.
Let's do that. Let's try that for some of these. So I said, are we subtracting X from Y? If we take Y and we subtract X, what does that give us?
400.
400. What about the next column? If you take Y minus X.
It gives us 400.
The next column, Y minus X.
400.
400. So we're noticing what is that relationship in this table?
So it increases in multiples of 400.
It increases by 400, or I mean, depending which way you go, right? Here it's decreasing, but we're noticing that it's increasing by 400 here. Let's go back to the context then. Remember, this first number here is your electricity bill. The Y value is the total expenses. Why do we think we're adding 400? What do you think that 400 could be?
Additional expense.
Yeah, I heard Sheila say additional expenses. Maybe it's the person's rent or something. Maybe they pay this much in electricity bills. The rent is constant. The rent is constantly $400. So the electricity bill might change, but they're always having to add in that $400 to get that total expense. It could be the rent. It could be, a variety of other things. I like how Sheila said that, like just additional expenses there. So we've got this as an equation. If we're thinking of it this way with the plus 400, what's an equation we could write with that?
S plus Y.
X plus Y?
I think the first equation is correct.
Mm-hmm.
Y minus X equals 400.
Yes, and let me clarify. This equation is a correct way to write this relationship. If you remember from yesterday, there's multiple equations you could write. One equation we could write instead, since you guys had noticed we're adding 400, I was curious if we could write an equation.
Y plus X, X plus 400 equals Y.
There we go. That's just another option too. We could say X, so that electricity bill, plus the $400 gives you Y, or the total expenses. That's another option there. There's one last table, table D. Do we see what the relationship is in table D?
Table D, X increases and Y decreases. So when X increases, Y decreases.
So it's X increases, let's pause there. As X increases, Y decreases?
Yeah.
Both of them are increasing.
You're saying both of them are increasing. Tell us why you think that.
Yeah, increasing in a multiple of 400. So more or less like table C.
Kind of like table C. So the first thing we said both X and Y are increasing. As you go from like left to right in that table, X is getting larger and Y is getting larger. Sheila had mentioned they're related with 400. You said it's similar to C. How is it similar to C?
Well, they are increasing. That means we have a constant of 400 somewhere.
A constant of 400 somewhere. Is it like what we were doing up here where I'm adding 400 to X to get Y?
No, we subtracting.
You can add 400 to Y to get X, and also you can subtract 400 from X to get Y. So it's vice versa.
Yeah. So it's like Sheila's saying, it's like the opposite of table C. I heard we could subtract 400 to get from X to Y, or the opposite of subtraction, right? If we wanted to go backwards, we could add 400. Nice. Let's come over to the context. So X is the monthly salary in dollars. Y is the amount deposited in dollars. What do we think this table is saying? What is this person doing?
That means the person has a constant amount that is being deposited along with his salary.
They've got a constant amount that's deposited.
400 being deposited every month, every paycheck.
I'm sorry, Deborah. Will you say that one more time?
I said a constant, just like is it Shirley or Hiro? Just like he said, I'm just buttressing it. That a constant of 400 deposited into the account on each paycheck.
Okay. So the amount deposited is here. Is our Y value? Is that constant? No.
For the deposit, no, it's not. It's just that it takes out 400 from the salary every month,
There
but it doesn't reflect the deposit.
Yeah, so that what you just described is that 400. The 400 is constant, but the 400 isn't the amount being deposited. The amount depositing is changed. You said 400 is the constant amount he's taking out. So whatever his salary is, he's taking out $400. We don't know to do what, but then the rest of it's getting deposited there. That's a great description of what's going on in this table. The last part to this is we've gone through and we've done a verbal description of what's going on in each of these tables. For some of them, you already went ahead and wrote an equation, which is awesome. The last part of this is I've got 4 equations here. These 4 equations go with those 4 tables we were just looking at. I'm gonna copy them up here so we can have everything in one spot. If you've got paper you've been taking notes on, you could always copy it. The equations down in your notes as well. 400x equals y. Okay, so these are our 4 equations that we want to match with these 4 tables. Go ahead, I'm going to give you guys about 1.5 minutes. See if you can match those 4 equations with table A, B, C, and D. For some of them, we've already written an equation, which might just make it even easier for you. And then after about 1 minute, we'll share out, okay? Take another 15 seconds to finish up. Just cleaning up our screen as you finish up. Okay. So for table A, which of those 4 equations did we match with table A?
400 plus x equals y.
400 plus x equals y. Ayoshile,
I
did you
think
match?
for table A, what I'm going to match is 400x equals y.
So we've got that. 400x equals y. Tell us why you're thinking it's that one instead.
Because 400 times 1 is 400. 400 times 2.5 should be 1,000. 400 times 6 should be 2,004.
So what are you doing right now? I'm hearing you give me these equations and these numbers. Where is this coming from?
The number of lapses run and the meter run. So if you run 1 lap, that means you've run 400 meters. So if you've run 2.5 laps, that means you've run 1,000 meters.
So you're using the values in the table kind of to test the equation to see if it's true.
Yeah.
If we tried testing this one here, the 400 plus x equals y, let's try it. Well, let's see what that looks like.
400 plus x, which is 400 plus 1, equals 401.
But it should say equals
No.
400. So we're seeing that equation can't be true because it's not describing our table here. Deborah, I'm going to come back to you. What do you think of this equation instead, the 400?
Yeah, that's true. It's 400x equals y. Sheila is correct.
So we've got 400x equals y for that first one. Table B, what about the next one?
X minus 400 equals y.
X minus 400 equals y. Deborah, Sheila, what do you think about that one?
Yeah, correct.
No.
Correct. That's x. Sorry, wait. X minus 400. No, wait. If we say x minus 400 equals y, it's
It's
not.
supposed to be like y minus x. Y minus. Well, you need to just change the variables.
Yeah, you just do. It's y minus. 400 minus x will give us the y. So it's meant to be 400 minus x to give us the y. So
400 minus x equals y. And I agree. I think this is the one we had before. Our problem is that's not one of our options here. So one of these other equations means the same thing as 400 minus x equals y. I think, Deborah, I heard you saying you started to agree with the x minus 400, and then I heard you say, wait, no. Why do we not think this equation is right?
Because if we have to x is 75, the meter from home, so you can't take away if you say you can't take away 325 from 75, it will give us a negative value.
Yeah. If I'm like using this point here, I hear you using that second column as a test point in our equation. We see that if we were subtracting 400 from the 75, it would be negative, but we should have a positive value there. So we're seeing this equation here isn't working out. Do we have a different guess for which one of these is our correct equation?
I think it's x plus y equals 400.
Tell us how you're getting that.
Okay, for the second option, if you have 0 plus 400, that's 400. We have 75 plus 325, that's 400. If you have 128 plus 272, still 400.
So you're noticing that each time these two numbers here add up to give you 400. And that was an observation. I'm not sure if we captured that earlier when we were describing in words. I'm going to push you guys to look at this equation, and instead of saying x and y in your head, say these descriptions. This equation here is saying that the meters from home plus the meters you are from school equals 400. One of the descriptions you had said earlier is that the total distance from home to school is 400. That's what this here is showing, that your distance from home plus the distance from school is a total of 400. You guys did great finding that one. So we've got these two here. We've got two equations left to match. Which one goes with C? Which one goes with D?
C is 400 plus X equals Y.
Sheila, I could tell you're just waiting to say that. C is which one?
400 plus X equals
400 plus X equals Y.
Deborah, you're agreeing?
Yes, I do.
Tell me why we're settling on that equation. Is this I think we wrote this equation before. That's why you were here. So then D is going to be.
It kept increasing in multiples of 400.
Yeah, I think we had even written on the table each time we're adding 400 to X to get to our Y, which means this last equation here, or sorry, this last table here.
X minus 400.
X minus 400 equals Y. And I think it was you who had noticed that to get from X down to Y, we have to subtract 400 each time, which is what this equation here is showing. Leaving this lesson here before you all go, I'm going to scroll down to our post-activity question. Now that we've spent a lot of time looking at tables today, what are some strategies you guys have noticed that can help us identify these relationships and write these equations? We had mentioned earlier trying to find an operation like addition or subtraction, multiplication or division, finding what that math operation is that relates them. Are there any other strategies we've noticed?
I think we can use the description to find the relationship.
I'm sorry, Sheila, will you say that one more time?
The description of values.
Yeah, using the description of the values, and I'm going to put and the context. If we've got like a context for what the table or the situation's talking about, using that to help us identify that relationship. Deborah, were you about to say something too?
It might not really be useful. Well, I just noticed that sometimes the value of X, the value of Y depends on X, and also sometimes the value of X depends on Y.
Yeah, that's really useful. So noticing which variable depends on which. One of the things we had done earlier, and then I went and I erased all our equations. But when you're writing these equations, Sheila, you had mentioned something yesterday that I thought was really valuable. When we were writing those equations, you had said, like, I noticed this equation we defined, we said like X equals something. Could we write an equation where we say Y equals something? And that's true. Lots of times you can write these equations multiple ways. For example, for table B, we originally wrote an equation where we said Y equals this. We were saying Y depends on this calculation. We could have also written an equation that says X equals something. So certain times, like, you're more often going to see maybe like X equals or Y equals, but figuring out like in your head, like which one depends on which can definitely help you with your equation. There's one thing I wanted to point out too to add to that list, and it's what you guys were doing right here. If you've got a pair of numbers you know should be true in the equation. So for example, I know that my equation should correctly show that if X is 1, Y is 400. You can always use those as like test points in your equation, like what Sheila had talked us through here with showing us, like, I see that it works. If I put in the X value and multiply it by 400, it gives me the Y value. That is really valuable when you're checking your equation. Or if it's like this where we know the equations and we're just trying to match them up, that is a really great strategy to use as well. Then I'm going to add to our list this idea of checking our equation with true, let's say, pairs of numbers. So if you know, like, if X is this, Y must be this, you can always use that information to help you check your equation. that is going to be where we stop for today. You guys did great. Let me tell you, this can be really challenging, and I'm so proud of you guys. You did an awesome job today.